Hey y'all, it's Becca. I'm a math, physics, and astronomy tutor here at Chegg. If you ever need such a tutor, feel free to hit me up at my profile, which is linked below. But today I'm going to talk to y'all about acceleration vectors. Now, we know that force is a vector, and by Newton's second law, force is related to acceleration, and acceleration also happens to be a vector having both magnitude and direction. So we're going to do an example problem where we figure out the net acceleration on a mass. So consider this figure. Two forces act on a 5 kilogram box right here. What is the magnitude and direction of the net acceleration of the box? Well, we know from Newton's second law that force is related to acceleration by simply multiplying mass by acceleration to get the net force, where acceleration is also a vector. So if we want the net acceleration, we have to also find the net force, which is great because we're given two force vectors here. We are given force vector 1 pointing in the y direction and force vector 2 pointing in the x direction. So we have, in matrix notation or vector notation, we have f1x up here and f1y down here. And in the case of force 1, there is not an x component because f1 is pointing entirely along the positive y direction. So f1's y component is the entirety of f1 in the positive direction, 15 newtons. And for f2, it is the opposite situation. For f2x, it will hold the entire magnitude of the vector because the vector is pointed entirely along the positive x direction, and none of the vector is pointed in the y direction. So these two vectors are actually quite simple to add. Our net force, then, is going to be the total x component of both f1 and f2. So we have 0 plus 10. That gives us 10. And the total y component of the net force will be the y component of the first vector added to the y component of the second vector. So 15 plus 0, and that gives us 15. Now, to find the magnitude of this net force, we use the Pythagorean theorem. We take the square root of the x component squared plus the square root, plus the y component squared, all underneath that square root. And in this case, we have 10 squared plus 15 squared. That gives us the square root of 335 because 10 squared is 100 and 15 squared is 225. So our total magnitude of net force is going to be roughly, popping that into a calculator, it's about 18.03 newtons. Now this value will be able to give us the magnitude of the acceleration. Because from this equation up here, if we wanted to solve for a, we would just have to divide both sides by mass. So acceleration is equal to force divided by mass, in magnitude, that is. Not necessarily direction. We'll do direction in a minute. But to find the magnitude of the acceleration, we take the magnitude of the net force, which is 18.03 newtons, and we divide by mass, which is a scalar quantity, no direction needed, and mass is given as 5 kilograms, which is perfect for our SI units. And that gives us an acceleration of roughly 3.61 meters per second squared, which is our unit for acceleration. So we have the magnitude of the acceleration that we got from the net force. Turns out the direction of the acceleration is going to be along the same direction as the force. So we need to figure out the direction of the net force as well. So the way we can do that is by recognizing that the resultant force is essentially pointing along this direction. And we can make a triangle out of that. The x component of this triangle is F2, or 10 newtons. The y component of this triangle is F1, or 15 newtons. So in order to find the direction of the net force, that angle there, we can use the tangent. Because the tangent of that angle is going to be the opposite leg, or the F1 component, the vertical component, 15, divided by the adjacent leg, which is 10 newtons, meaning that we can simply take the arctangent, or the inverse tangent, of our y component, 15, divided by our x component, 10, and that gives us an angle of roughly 56.31 degrees. Okay, so since the net force is pointed in a direction of 56.31 degrees with respect to the positive x direction, that tells us that the acceleration is also pointed in that direction, with a magnitude of acceleration of 3.61 meters per second squared. So this is one example of how to find the net acceleration acting on some mass. If y'all have any other questions on this, feel free to hit me up, or any other physics tutor here on Chegg. Okay? Bye, guys.